Hello, today we are going to discuss Lagrangian and Hamiltonian mechanics. Before entering into the Lagrangian Hamiltonian mechanics, we need to discuss uh, three things. One is space and time, second one is frame of reference, third one is how Newton's second law is uh, related to the conservation laws. Okay, mechanics is a branch of physics which deals with the physical object in the motion and the rest under the influence of external and internal interactions. Mechanics had developed in ancient times on the basis of observation on the motion of material particles. In theoretical, the relation between force and motion, Newton announced his famous laws of motion in 1687. The mechanics based on Newton's law of motion and alternatively developed by Lagrangian, Hamiltonian, and D'Alembert and others is called classical mechanics. When this mechanics deals with the Newton's laws and their consequences, it may call as Newtonian mechanics or vectorial mechanics. Here is the space and time or frame of reference. There are three assumptions on that. One is space and time are continuous. Another one is the motion of particle in space can be described by knowing its position at a different instant of time. Third one is there are universal standards of length and time. Now, here is the important thing, frame of reference. What is frame of reference? If you imagine a coordinate system attached to a rigid body, then we describe the position of any particle relative to it. Then such coordinate system is called frame of reference. The simplest example of frame of reference is Cartesian coordinate system where the r equal to position equal to x I cap plus y j cap plus z k cap. Let r be the radius of the particle from some given origin and v its velocity. So therefore v equal to dr divided by dt. The linear momentum of a particle is defined as the product of the particle mass and its velocity p equal to mv. The particle may experience of forces of various types, example gravitational or electrodynamics. The vector sum of these forces exerted on the particle is the total force F. The mechanism of the particle is contained in Newton's second law of motion. It states that there exists a frame of reference in which the motion of the particle is described by the differential equation F equal to dp divided by dt or p dot. F equal to d by divided by that p is the linear momentum. Then F equal to dv divided by dt. F equal to mv. Newton's second law. Okay, where A is the vector acceleration of the particle d square r divided by dt square. If external force acting on the particle is zero, a frame of reference in which the Newton's law is valid is called an inertial or Galilean system. The law of inertia was first stated by Galileo. Therefore, the inertial frame of reference also named as a Galilean frame of reference. So F equal to dp divided by dt or d divided by dt into mv equal to 0, which means p equal to constant. Many of the important conclusions of the mechanics can be expressed in the frame of conservation theorems, which indicate under the what conditions various mechanical quantities are constant in time. So this is the direct evidence of conservation of linear momentum. So this conservation of linear momentum is going to give important relation Newton's second law. By observing this Newton's second law only, we can observe this one. So in the absence of external force, here the P quantity, some quantity equal to constants. That's what they're saying. The conservation theorems which indicate that under what conditions various mechanical quantities are constant in time. Okay. So this is a direct evidence. P equal to constant if force equal to 0. In the absence of external force, the linear momentum of particle is conserved. So conservation theorem for the linear momentum of particle, if the total force F is 0, then P dot equal to 0, which means the linear momentum P is conserved. So next class we are going to discuss conservation of angular momentum.